Hello my dear students, welcome to the class of 12th English medium. The subject is statistics, part 2, chapter 1, probability, presented to you by Vitan sir. Now, in this particular tutorial, I am going to explain about some of the spatial events of this chapter. Starting with event, we will be defining each and every events, but before that let us define what is event. A subset of a sample space of a random experiment is called an event. A subset I am talking about, it is usually denoted by A, B, C, sometimes even by A1, A2, A3, etc. This is a universe, that is a sample space U, and this circle denotes the elements belonging to event A. Any event A which is related with random experiment is a subset of U. In notations, A belongs to U, or A is a subset of U. This is the definition of event. Next, impossible event. Now this is something which I have already explained in the very first tutorial of this chapter, but let us again understand this concept using some statistical methods. It is an event which never occurs. It is denoted by you know what it is called, 5 or empty curly brackets. It can also be called an empty set. Next is certain event. Just like previously impossible event, let us understand it in a statistical viewpoint. It is an event which always occurs. It is denoted by spatial subset capital U. It means that the event containing whole of the sample space is a certain event. That means the whole of the sample space itself is a certain event. So if an event contains all the elements of the sample space U, then it becomes a certain event. And if an event does not contain a single element of the sample space U, then it becomes an impossible event. Complementary event. Let's start with something new here. If U is a finite sample space and A is one of its events, then set of all elements of U which are not part of A are called complementary event of A. That means all the elements which are not in A are the complementary elements of event A dash. So this is U. Now this black circle is A. So the highlighted part, which is not part of A but it contains every other things which is the part of U, we will call it A dash. That is the complementary event. So right now the highlighted part here is the complementary event. So I think you are getting the idea what I am trying to say. They are denoted by A bar, A dash, or A C. Okay, but usually we just use A dash. Next is the intersection of events. Suppose A and B are two events of U, then event with common elements of A and B is called an intersection event. That means this is the event which has the common elements between A and B. Now this is sample space U. These are the events A and events B. The common part between these two events you can see is the highlighted here part. That highlighted part is denoted as A intersection B, that is A reverse U, you can say B, but we call it A intersection B. So that is the intersection of events, okay, the common part between the two events. Next is the union of events. Suppose A and B are two events of U, then event where either A or B or both the events occur is called union of events. Basically, everything which is a part of A and B is called union of events. This is the sample space U. These are the two events A and B. Now when I highlight everything which is a part of A and a part of B, it becomes union of events and it is denoted as A union B. We call it A union B. So it includes everything which is a part of A and B. Next is mutually exclusive events. Now, suppose A and B are two events of sample space U, then if A and B never occur together, never occur together, they are called mutually exclusive events. That means if A happens, B cannot happen. If B happens, A cannot happen. That means they can never happen together. Means there is nothing common between these two events. Then they are called mutually exclusive events. Okay. So this is the sample space U, and these two are the events, and as you can see there is nothing common between A and B, so we can denote it as A intersection B is equal to 5. That is the null set. That means there is nothing common in between them, so we cannot find a single value for their intersection. So this is the intersection of events. Next we will start with the difference events. Suppose A and B are two events which are part of a sample space U, then event where A occurs but B does not occur, that means A must occur and B cannot occur, we will call it the difference events A and B. That means A happens but B does not happen. Now let's see how it can be depicted in a Venn diagram. This is the sample space U, these are the events A and events B. Now here I have to show a part where A is there but B cannot be there. So this is how I am going to highlight this part. As you can see, the highlighted part has A, but the center part, which was the the common part between A and B, that part is not highlighted because that is a part of A but that is also a part of B, which should not be there. So I have only highlighted the part which is specially only belong to A, and that we are going to show as A minus B. But the other ways of showing it are A intersection B dash, A minus A intersection B, and A union B minus B. So these are the other methods of how we can denote the difference events A and B. Now as you can see here, if I am getting a difference event of A minus B, naturally there could be a difference event for B minus A. So similarly, event where B occurs but A doesn't occur is called difference event B and A. This is just the opposite of the previous event. Here U is the sample space, A and B are the two events, and I am only going to show you the part which belongs to B, but the part which belongs to A should not be there. So this is how you show the difference event B and A, and it is denoted as B minus A. Then there are other methods of calculating B minus A, which are A dash intersection B, B minus A intersection B, or A union B minus A. Just the opposite of the previous difference event. Okay, nothing new here. We are just finding the difference event. So difference event is getting a difference of the events. So if A occurs and B does not occur, that's difference event AB. If B occurs but A does not occur, then that's difference event BA. Moving on to the exhaustive events. Now suppose A and B are the two events which are part of the sample space U, then events A and B are called exhaustive events when their union is the sample space U. That means when the two events A and B unite, they consume the whole of the sample space, nothing else is left. So then those events will be known as the exhaustive events. Now this is the sample space U, and now these are the two paths, event A and event B. So now when you add these two events, it naturally creates the sample space U. Okay, of course when you add A with B, you get the whole sample space. So it is denoted as A union B is equal to U. So this event is known as the exhaustive event. When you add two events, you get the sample space, it becomes exhaustive events. The notation here is A union B is equal to U. Next are the mutually exclusive and exhaustive events. Right now we are combining two types of events into one. The mutually exclusive event, we know there is nothing common. Exhaustive events, when we combine the two, we get the sample space. So suppose A and B are the two events which belong to sample space U, and if there is nothing common between A and B and their union is U as well, then these events are called mutually exclusive and exhaustive events. Now there is not a Venn diagram which I can show you here, but how it is denoted? So symbolically it is mutually exclusive, so A intersection B will be null set, and it is exhaustive, so A union B will be the sample space U. So these two system when combined creates mutually exclusive and exhaustive events. The last event of this particular video tutorial, elementary events. Events formed by all the subsets of single elements belonging to sample space U of a random experiment are called the elementary events. Right now I am talking about a sample space U. So if I take out single elements of the sample space U, then all those single elements are known as the elementary events. So each single element becomes an event. Now these events are always mutually exclusive and exhaustive. Why? Because all the events are single, so there is nothing common in between them, and when we combine all of the elementary events, it becomes a sample space. Now let us take an example here. While tossing a coin, we know that the sample space is H and T. When we toss a single coin, the sample space is H and T. So naturally the events H and T will be the elementary event. Getting the point here, that the sample space consists of two events H and T. So event H and event T is considered an elementary event because there is only one element in this event, when there is nothing common in between them, and when we combine them it becomes the whole of the sample space. So with this I end today's tutorial. We studied about the most IMP types of events which will be studying continuously in the later videos using some practical formulas and sums and methods, and therefore remember each and every of these events properly. Write them down in your notebooks with the definitions, with Venn diagrams. I have tried to explain them better with good quality images and all that, so that you can understand it better. Next time we will meet with the exercise 1.1. Yes, the 1.1 exercise is based on these types of events. We will try to solve the sums and understand how these events work. So till then, stay tuned, stay home and stay safe.